Okay, so yesterday we were talking about sum and difference with cosine, right? And the purpose of this is so that you can use values on your unit circle to find exact values of angles that aren't on the unit circle. Okay, so for example, if I have 5 pi over 12, how can I rewrite that using two radians that are currently on my unit circle? Nope, can't multiply. It has to be addition or subtraction. No multiplication. We have a pi over 2. So if we did, so 5 pi over 12, right? So if I did pi over 2, that means that's 6 pi over 12, right? And that would leave me with, not plus, I would minus, but is pi 12th on our unit circle? No, so that one wouldn't work. Okay. Well, how about you separate 5 pi? Well, 5 pi, think about it as addition, right? If I have 2 pi over 12 plus 3 pi over 12, does that give me 5 pi? Yes. If I reduce these down, what do they be reduced down to? And pi over 4. Are those values that are on our unit circle? Yes. So therefore, these would be our cosine values. Does that make sense? Yeah. So taking what you have and you're breaking it down. Now, if that was hard for you, what is your other option you could do? You can convert it to degrees and then figure out what's being added and subtracted, right? All right, so we know that this will be our A and this will be our B. So we're doing cosine of A plus B, which would equal cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. We established that our sine and our cosine values are what values of our unit circle? The ordered pair, right? Your x's and your y's. So looking at our ordered pairs or thinking about our ordered pairs, what is the cosine of pi over 6? Square root of 3 over 2. Perfect. What is the cosine of pi over 4? Perfect. Minus what is the sine of pi over 6? And what is the sine of pi over 4? Okay. And now we're going to simplify it. Remember when you're multiplying fractions, it's numerator times numerator, denominator times denominator. So we're going to multiply our fractions. And we get the square root of 3 times the square root of 2 is square root of 6. 2 times 2 is 4. 1 times the square root of 2 is square root of 2. And 2 times 2 is 4. When the denominators are the same, you can do what with the numerators? Combine them. So we get square root of 6 minus square root of 2 all over 4. And that equals the cosine of 5 pi over 12. Yes. All right, so just recap. Yesterday we did it as a degree. We had 15, and we decided to do it as subtraction, 45 minus 30, right? And we plugged in, we found in cosine of 45, cosine of 30, sine of 45, sine of 30. Today, we now use those pretty much the same values, right? We still use pi over 4 and pi over 6, correct? Yeah. But instead of subtracting them, we ended up adding them, and we ended up with the same, very similar output. Okay, how do we feel? Still good? All right, now let's go backwards. Okay, so if we're going backwards, it says find the exact value of cosine of 87 cosine 93 minus 80 minus sine of 87 sine of 93. Okay, so we're going to go backwards to figure out if there's a better angle that we can use to find this. So if I want to undo this, which rule am I following? It's going to be this one, right? Because these two are being subtracted. So to undo this, it becomes cosine. This is my A and this is my B of 87 plus 93. And what is 87 plus 93? 180. So I'm looking for the cosine of 180. Do we know the cosine of 180? And what's the cosine of 180? -1. How do we feel about going backwards? Terrible. You're given the expanded and you have to condense it and then rely on what you know.
Do we have to do that with radians too?
I mean, you should be comfortable being able to add the radians and going backwards, yes. What is that face? Okay. Good? Cool. Our geniuses. All right. Up next are co-function rules. So I'll give you a moment to write down the co-functions. So here are your co-functions. Co-functions are saying that it's based off of 90 degrees. So think about your complementary angles for the most part. But it's telling you that if you have an angle and you subtract it from 90 degrees, the cosine of that angle is going to equal the sine of that angle. And then it keeps going with the rest of the patterns that you can see. So someone sat in a corner and realized these patterns. Like, oh my gosh, guys.
How bored do you have to be?
I'm not sure. I got an order that she canceled with me, so he's not on the list. Yeah, that was what I would go to. I'll double check, but I'm pretty sure hers was a while back. Oh, I don't know about it. Okay. Do we got them down? Are we ready to use the co-functions? All right. So up first, we have, it says find one value of theta or x that satisfies each of the following. So we have the cotangent theta equals tan of 25, okay? So the cotangent theta equals tan of 25. When we look up here, we can see that with this angle, we can figure it out because if the tan of 25, we can plug it in and evaluate, right? So we would be using this rule here, that the cotangent of 90 degrees minus theta equals tan of theta. Okay, so if we know if we're plugging this in and we know that this is 25, to find that unknown angle, we're going to subtract it from 90. Does that make sense? So we're going to do cotangent 90 minus 25. Because in order for this to be a true statement, So therefore, what would cotangent have to be? 65. So the cotangent of 65 is going to equal the tan of 25. So remember I said they're going to be complementary angles for the most part? Because of that 90. So minus the 90. All right. Next, we're gonna do this one. So now we have sine theta equals cosine of negative 30. So we're going to be using the sine rule, the sine cofunction. So we have sine 90 minus theta equals cosine theta. We know that our well, it's really weird when it's theta and then it's theta. We're gonna just change this one to an x. Sine x, we're gonna figure out what that is. So we know that our theta is negative 30. So when I plug this in, it becomes sine of 90 minus negative 30 equals cosine of negative 30. So what would that value be? A negative times a negative is a positive. So it becomes sine of 120 equals cosine of negative 30. So your angle would be 120. How do we feel about this with degrees? I said, how do we feel about it with degrees? You said good. Okay, so now that we're doing radians, your 90 is going to be replaced with pi over 2. That's it. That's doable, right? You're okay. You're geniuses. I believe in you. All right. Now, this one's a little different because it wants us to find what was added or subtracted to 90. What was subtracted from 90, right? Does that make sense? Because we don't know this outside. So we have cosecant theta, 90 minus theta equals secant theta, right? So we don't know what this value is. But we know together that 90 minus the x has to equal 3 pi over 4. We're not going to use 90 though. What we're going to use? So we know pi over 2 minus x has to equal 3 pi over 4. And how would we evaluate that? We subtract the pi over 2. So we're going to subtract pi over 2. So minus pi over 2 to cancel it out over here. So we're left with negative x equals. This is where you can do a little quick chopstick, right? 3 times 2 is minus 4 times pi is all over 4 times 2, which is 8. So that gives us 2 pi over 8, which equals pi over 4. Does that make sense? Okay, it's a negative x. So therefore the pi has to be, so x equals negative pi over 4. So that's what the x would have to be. Hopefully doing chopsticks makes life with fractions a little friendlier. No? Yes? Makes it not as intimidating, right? You all are always quick to cross multiply. So here's an example of how to use your cross multiplying to help you with fractions. Okay. All right. So the difference between example C and example A and B is that for C, we didn't know what our angle we were subtracting from 90, right? So we had to find that angle. All right. Are we good? Cool. All right. So keeping in mind that trig functions are periodic, the solutions in our next example are not unique. We can only give one, there's infinitely many solutions. That's because the sine functions, remember our waves, they go on forever, right? They're periodic. So when we are solving, we're gonna just keep in mind that we're only gonna face the interval that they give us or the quadrant they tell us we're in. Does that make sense? There should be some type of limit given to you. So if either angle A or B in the identities for cosine of A plus B and cosine of A minus B is a quadrantal angle, then the identity allows us to write the expression in terms of a single function of A or B, meaning that here, for example, if I have the cosine of 180 minus theta as a trig function, I can go through and figure out what it's going to equal, because in the end, cosine has its own value of either 0 or 1, right? So we're going to work it out just as using theta in its place. So first off, we're following cosine difference. So it becomes cosine of 180 times cosine of theta plus sine of 180 times sine of theta. Okay, what's cosine of 180? -1. Remember that? So it's -1 cosine theta. And what's sine of 180? 0. So no matter what the angle is, cosine of 180 minus theta is going to always be negative cosine. That's an ugly 180. I couldn't even accept it. I don't know if that's much better. So that's the conclusion, is that you can figure out what that value is just from theta. So from here, we know that whatever cosine of 180 minus theta equals negative cosine theta. So from there, you can kind of create your own trig identity for the difference of cosine, specifically with 180. So it's very similar to the cofunction rule. Remember how with the cofunction, you had your 90s, 90s, 90s? So now you're talking about in terms of 180, what does that look like? That was just a work all there for you. So when you look at it, it's prettier. All right. So now we're here. Suppose that the sine S equals 3/5 and cosine of T equals -12/13. And both S and T are in quadrant 2. Find cosine of S and T. Okay. So the angle takes place in quadrant 2, which means that our angle value has to be between 180 and 90 because it takes place in quadrant 2. Oh, I have to put my chart there. So it says find cosine of S plus T. So remember, if we're doing cosine of S plus T, that equals cosine of S times cosine of T minus sine of S times sine of T. And we're going to plug in the values that we know. All right. And we're going to talk about how to find the ones that we don't. Cool. So plugging in what we know, do we know the cosine of S? Not off the top of our head. Do we know the cosine of T? Yes, it says cosine of T is -12/13. Do we know the sine of S? Yes, sine of S is 3/5. Do we know the sine of T? We do not know the sine of T. Okay, so now we've gotten as far as we could without us having to do additional work. Now it's time to do a little bit more work. If I know the sine of S, we're going to go back to using what we learned in our ratio rules for sine, cosine, and tangent using X's and Y's. Does that remember? So we know that sine equals our y over our r. Do y'all remember that? And we know that cosine equals our x over our r. So if I know that sine is 3 over 5, are y'all with me? Can I figure out what the value of x is? Remember, their relationship is x squared plus y squared equals r squared. If I have my y and my r, can I solve for my x? We surely can, because it's a triangle and it creates a special triangle. Does anyone remember what kind of triangle this is? Right triangle. So we have 3 squared plus x squared equals 5 squared. And it's going to be 4. There we go. So our x equals 4. So therefore our cosine of s equals -4 over 5. Why is it a negative though? It's in the second quadrant. Okay. Now we got to find the sine of t with the same thing. So this time we know that the cosine that was given was -12 over 13. So that tells us that x equals -12 and r equals 13. So if I have y squared plus -12 squared equals 13 squared. That gives me 169 minus 144. That's 169 minus 144. 25. And then what's the square root of 25? So y equals 5. So the sine of t equals 5 over 13. So do I have the rest of the information I need to fill in so that I can evaluate? Why, yes, I do. I now know u and I now know u. So we end up with cosine of s is -5 times cosine of t, which was given to us, -12 over 13, minus sine of s, which was given to us, 3 over 5, times sine of t, which we found, which was 5 over 13. And we're going to do a little bit of math. -4 times -12 is +48. And then 3 times 5 is 15. And 5 times 13 is 65. So 48 minus 15 over 65 equals what? 33. So we get 33 over 65 is our final answer. So it seems like a lot of work, but it's a lot of small work, light work, right? Okay. And that is the end of 5.3. What are your questions? Was it terrible?
That last part.
It's a buildup of everything, of all your knowledge, Andrew. You did just fine on it.